Alright, I want to talk to you some about converting from acyclic forms of sugars, like this one shown right here, into cyclic forms of sugars. Alright, these are called, the cyclic forms of sugars are called Haworth structures, and they look a little bit different to these. These look kind of hexagonal. They look like hexagons with an oxygen being part of that ring, but I'll show you more here in just a minute. So there are basically 3 steps to do here. Alright, the first step is to start off with the Fischer projection of the sugar that you have. Make sure you can tell how many carbons they have. 6, 5, 4, 3, 2, 1, so it's got 6 carbons. There's an aldehyde up on top. You've got OHs on 5 of the carbons. Carbons 2, 3, 4, and 5, okay? So, like I said, there are 3 steps involved here. Step 1 is to take the Fischer projection and rotate it clockwise 90 degrees. If you will, imagine that this is standing up and you knock it over and it falls down flat. So if this line was vertical for the carbon backbone over here, we're going to draw it horizontal. So that's what I'm going to do. I'm going to draw this horizontal. If this was on top when it falls this way, carbon 1 is going to be here. So I'm going to draw on, here is our aldehyde. Alright, so that's 1. Now when this went down, hopefully you guys can see that the OH here is going to be pointing up when it falls down. You've got OH up, the hydrogen down. So that's carbon 2. Carbon 3 is exactly the same. We've got OH up, the hydrogen down. When we get to carbon 4, see that it's the opposite. We've got the OH down and the hydrogen up. Then when we get to carbon 5, we have the OH up again, as we had for carbons 2 and 3, and the hydrogen down. And then right at the end here we have our carbon with the 2 hydrogens and then the OH. Alright, so that's step 1. Literally all we've done is take this and rotate it 90 degrees. If it helps, I'm going to put the carbon numbers on here and label them just so you can see what's what. Alright, so in here carbons 1 through 6, here carbons 1 through 6. Now step 2, this is where a lot of people tend to get hung up on this. What we have to do is to take this structure and fold it up into a hexagon. So we've got to fold into a hexagon, much so we got something that looks sort of like this, alright? And here's what we're going to do. You're going to imagine that you're taking the carbons on this side and rotating them around to the back. So carbons 1, 2, 3 are going to be the ones in the front of your hexagon. So let me show you what I mean by that. We're going to start off with the carbon that was the aldehyde. I'm just going to draw that out again down here. So that's carbon 1, and I'm trying to draw these in the form of a hexagon. So what we're doing is I'm going to try and draw out the shape of a hexagon here. All right. If it helps, I'll draw a little bit of perspective here, showing that these bonds are actually coming out towards you a little bit, because these are the ones in the front. I don't know whether that helps or not. But if I label these again, I got carbon 1, 2, 3, 4, 5, and what we're going to actually do at this point is, you see here carbon 5 has the OH on it. We're actually going to show that OH here, because this OH is going to do something with this carbonyl group here in just a minute. And what we do at that point, you see on carbon 5 here, there's the OH. What we usually do is show the CH2OH group pointing straight up. Now what we have to do at this point, and so this one's carbon 6. What we have to do at this point now is put on all the OHs, alright? And the thing to remember is, if the OH in this structure was pointing up, in this, what's almost a Haworth structure, is also pointing up. If the OH points up, the hydrogen's pointing down, just as it was here. For carbon 3, the OH is pointing up, the hydrogen is pointing down. For carbon 4, the OH is pointing down, the hydrogen is pointing up. For carbon 5, this is what we did for carbon 5. I haven't put the hydrogen on there. I'm going to obscure that 5. The hydrogen is right there. All right. That looks a little bit messy. My apologies for that. That's step 2. And then the last step, step 3, is to join this oxygen, for this OH, with carbon number 1. We're actually going to take these and join them together. And what we're going to get is a structure that looks, hopefully you guys can see what I'm doing here. If I draw out this hexagon again, I'm going to take this oxygen and bind it to carbon number 1. So this oxygen is actually going to have a bond to carbon number 1 here. All right. Now, I know there was a hydrogen on here, and here there's not. We'll get to that in just a minute. But before we do anything else, I want to make sure that we put all the other groups on. All right? So if this is carbon 1, 2, 3, 4, and 5, we're going to put the OHs and Hs exactly where they were before. So for carbon 2, we'll come back to carbon 1 in a minute because it's kind of important. So for carbon 2, can you see that as over here it was the OH was up, it's still going to be up here and the hydrogen's down. For carbon 3, the OH is also up and the hydrogen's down. For carbon 4, the OH is down, the hydrogen is up. For carbon 5, the hydrogen's down, we have the CH2OH here. All right. Now, what's important about these two carbons here is when I join these two together, I'm losing the hydrogen from this oxygen, and it's actually going onto this carbon. Because what's going to happen here is when these two join, by moving my hydrogens around, I'm going to create another alcohol on this carbon. But if I was to ask you, does the OH go up or down? You can't tell anything from here because, well, there was no OH on this carbon before, so actually I'm not sure. It turns out that you can draw it both ways. You can draw it up. So if two people showed me an answer to this question, sorry, I don't know what's going on with this, me drawing H's. It looks like somebody's having a baby over here or something. Hang on a minute, let me try it again. So we can draw the OH pointing up. Let me try it now and see if it works properly. Okay, there we go. We can draw the hydrogen down. If I had two people give me an answer for this, and one person put the OH up and the other person put the OH down, actually technically neither of those is wrong, unless I ask you for some extra information. So I'm going to show you the other structure here that somebody could have drawn. All right, it's exactly the same thing as what we drew before. All right, in this case I have the OH on carbon number 1 pointing down. Here it's pointing up. For all the others, the relationship's exactly the same. On carbon 2, the OH was pointing up, so it still is. For carbon 3, the OH was pointing up, so it still is. Damn, what is going on with that? For carbon 4, the OH is pointing down, and so it still is. So the hydrogen's up. And then for carbon 5, the CH2OH originally was pointing up, so it still is now. And that hydrogen is pointing down. So these two structures here, these are the Haworth structures of this sugar. The only difference is, I'm hoping you guys can see these are not the same because in one the OH points up, in the other the OH points down. These are known as, this carbon here is known as an anomeric carbon because when this cyclizes, the OH can go up or the OH can go down. It turns out that when the OH goes up, what you get is something called the beta anomer. These two structures can be called anomers. The beta anomer because the OH points up, and then we have the alpha anomer here because the OH points down. So those are the three steps to take a open chain acyclic Fischer projection. You rotate it 90 degrees, you fold it up into a hexagon, and then you put the OH on. You join these two up and you put the OH on. either carbon. Just so everybody is sure, I'm going to label these carbons so you guys can see the numbering has not changed at all from any of these structures. Here it was 1 to 6. When we folded up, it was 1, 2, 3, 4, 5, 6, and it still is 1, 2, 3, 4, 5, and 6. So the thing to remember, the oxygen with the OH that's part of the cyclization, that's always the OH that's on carbon 5 that does that. Carbon 5, carbon 5, carbon 5. And that's how you convert from an acyclic to a cyclic structure for a sugar.